Welcome back to the Deep Dive. Today, we're looking into something huge, a really fundamental shift in how nations are thinking about defense strategy.
That's right. If you're picturing military planning like old maps and rigid formations, well, the sources we looked at suggest that picture is rapidly becoming history.
It's moving away from those, let's say, pre-scripted, doctrine-heavy approaches.
Exactly. The whole game is changing. Strategic advantage isn't just about having the most tanks or ships anymore, platform mass.
It's more subtle now.
It's about the quality and maybe more importantly, the speed of decision making. That's the new decisive factor.
Speed. Okay, so that's our focus for this deep dive then. Unpacking this whole concept of decision superiority.
Yes, what it really means, how AI is making it achievable, and crucially, the big risks, ethical and strategic, that pop up when security starts operating at machine speed.
Makes sense. So to get where we're going, maybe we should touch on where we've come from. Traditional military doctrine.
Right. Think of traditional doctrine as the official playbook, how to fight, all codified. It meant rigid command structures, set responses for set situations.
Which worked okay when things moved slower, I guess.
It worked for its time, but the modern digital battlefield, it's just too fast, too complex.
Information overload.
Precisely. That old way, that doctrine, is just too slow, too cumbersome to adapt. It's like trying to use a dusty old encyclopedia set when you need Google Maps right now.
Okay, so that old encyclopedia is out. What's replacing it? You mentioned this idea. Algorithmic doctrine.
That's the term catching on. Algorithmic doctrine isn't a fixed manual. It's strategy that's actually learned from data.
Learned by the machines.
Learned by AI systems, yes. And it's constantly revised, iteratively updated, all at machine speeds. It's adaptive, almost alive.
So not a static plan at all, but a dynamic process.
Exactly. The core ideas are adaptability, always optimizing based on incoming data and operating at timescales way beyond human thinking speed. It's a fundamental shift in structure.
And this isn't science fiction, right? This is happening now.
Oh, absolutely. We're seeing this shift in major programs already. Look at the U.S. Department of Defense's Project Maven.
Maven, right. That's about intelligence, surveillance, reconnaissance, ISR video, isn't it?
Yes, specifically accelerating how that video data is used. The problem is just the sheer volume.
Too much footage for humans to watch.
Way too much. Petabytes coming from drones, satellites, human analysts just drown in it. Maven uses AI to sift through it all instantly.
Doing what exactly?
Identifying patterns, classifying objects, flagging potential threats, basically getting crucial information out for targeting or warnings far, far faster than humans ever could.
Okay, that's one concrete example.
Yeah.
And you mentioned another concept, DARPA's mosaic warfare. That sounds different.
It's maybe even more profound conceptually. Mosaic warfare challenges the whole idea of what a military system even is.
How so?
Well, instead of pouring billions into one giant, super complex fighter jet that does everything but takes decades to build.
Which is the traditional way.
Right. Mosaic envisions using lots of simpler, cheaper, maybe even expendable systems, drones, sensors, shooters, all networked together.
Like building blocks.
A mosaic.
Exactly like a mosaic.
Yeah.
You create these modular, composable kill webs. The complexity isn't in the individual piece, the single expensive platform.
It's in the network connecting them.
Precisely. The strategic edge comes from the network's intelligence, its ability to configure and reconfigure itself on the fly, dynamically.
Adapting to threats as they emerge, without waiting for a human commander to redraw the entire plan from scratch.
That's the core idea. Instant adaptation based on the real-time situation.
And this need for speed and connectivity, it's not just one country's problem. There are international efforts too, right? Like within NATO.
Yes, initiatives like Coalition AI Enablement. A big focus there is just getting everyone on the same page with data standards.
Why is that so important?
Interoperability. If ally systems can't talk to each other because they use different AI models or data formats, everything slows down. In a crisis, you need seamless data sharing to react together at, what do they call it?
The speed of relevance.
Yeah.
That's the goal, making sure allied AI systems can work together effectively and instantly.
So Project Maven, Mosaic Warfare, NATO's efforts, they're all driving towards this one central goal, decision superiority.
That's the name of the game now. It's the ultimate goal in modern conflict.
And how would you define that? Decision superiority.
It's the ability to see what's happening, predict what might happen next, decide what to do, and then act on it faster, more accurately, and with more confidence than your adversary.
Getting inside their decision cycle.
Exactly. Outthinking and outpacing them.
And AI is the key enabler here because it speeds up that famous cycle, the OODA loop.
The observe, orient, decide, act loop, yes. Colonel John Boyd's concept. Every military entity goes through it, consciously or not. AI drastically shortens that loop.
How does it do that? Where's the compression happening?
Think about the first two steps, observe and orient. You've got data flooding in, satellites, drones, cyber sensors, ground sensors.
Daily.
Right. AI automates the fusion of all that disparate data. It figures out what's important, prioritizes threats using predictive models, and even generates potential courses of action, all nearly instantaneously.
So it takes the raw data processing off the commander's plate.
It aims to. The idea is to move the commander from sorting through mountains of data to making informed decisions based on synthesized, prioritized options.
But wait, if AI handles observe and orient so quickly, doesn't that just shift the bottleneck? Doesn't the commander now face immense pressure at the decide stage, having to evaluate AI-generated options at high speed?
That's a really critical point, and it's a definite tension. The goal isn't to overwhelm the commander with more decisions, but with better, more timely options.
How did that work in practice?
Ideally, the AI presents, say, 2 or 3 highly relevant, vetted courses of action, along with predicted outcomes and confidence levels. So the commander isn't wading through raw data, they're evaluating focused intelligence.
Which means the speed and quality of that AI-processed information become absolutely central.
Central to everything. Deterrence, crisis management, escalation control. It all hinges on having that information advantage.
Okay, so the operational upsides are clear. Speed, precision, advantage. But, as soon as we talk about AI making or even shaping these kinds of critical decisions, the ethical alarm bells start ringing pretty loudly.
They absolutely should. And that brings us squarely to the challenge of control, specifically meaningful human control.
Define that for us. What does meaningful mean here?
It's a fundamental principle, especially vital when we discuss lethal autonomous weapon systems or laws. It means humans must retain ultimate control and authority over the use of force. Key decisions, especially life and death ones, cannot be fully delegated to a machine. It's the ethical and legal backstop.
But the whole point of these systems is speed. Doesn't operating at machine speed inherently put pressure on that human control?
It creates immense pressure, and if that control starts to erode, the immediate consequence is a crisis of accountability.
Accountability, meaning?
Meaning, if an autonomous system makes a mistake, initiates a strike, it shouldn't have, due to a glitch, bad data, or some unforeseen interaction, who is responsible? Legally, morally, strategically. Without clear human control, assigning accountability becomes incredibly difficult, if not impossible.
That's a huge problem. And beyond that fundamental issue, there are also risks for the human operators working with these systems, right?
Yes, there's a dual risk they face daily. First is what we call algorithmic opacity, the black box problem.
Meaning the humans don't know why the AI is recommending something.
Exactly. Especially with complex deep learning models, the internal reasoning can be so intricate, so mathematical, that even the designers might not fully grasp why it reached a specific conclusion. The operators certainly can't audit the AI's thought process in real time.
So the AI says, target X is the priority, but the commander can't quickly ask why target X and not target Y without losing that speed advantage.
Precisely. They're often forced to trust the output without fully understanding the input or the reasoning, and that lack of transparency directly fuels the second risk.
Which is?
Automation bias. It's a well-documented psychological tendency.
The tendency to just trust the machine.
To overtrust it, yes. Imagine you're a commander under incredible stress, maybe seconds to decide. The AI system has been right 99% of the time before.
You're going to go with its recommendation.
You're very likely to accept it uncritically, even if your own intuition or experience hints otherwise. This bias can lead operators to essentially switch off their own judgment, which is incredibly dangerous in high-stakes situations.
Okay, so we have lack of control leading to accountability issues, we have opaque algorithms, and we have operators potentially overtrusting those algorithms.
Yeah.
If we scale this up to the strategic level, what's the big danger?
The sources point very clearly to the risk of flash wars. This is probably the most destabilizing potential outcome of this AI-driven speed race.
Flash wars. Like a flash crash in the stock market, but with missiles.
That's a good analogy. It refers to the potential for rapid, automated, and crucially inadvertent escalation of conflict.
How would that actually happen? Paint a picture for us.
Imagine two adversaries, both equipped with these high-speed AI-enabled defense systems. Nation A's AI detects sensor readings it interprets, based on its algorithms and predictive models, as a potential imminent attack.
So it reacts defensively.
Instantly, it might launch countermeasures or shift forces all within milliseconds, but Nation B's AI observes those actions.
And interprets them as hostile.
Possibly. It might interpret Nation A's defensive move as an aggressive first step and launch its own counter-response, again, almost instantly.
So the conflict escalates in seconds, purely through machine interactions, before any human leader even gets the alert on their screen.
That's the nightmare scenario. The pace of engagement is driven by algorithms interacting, potentially spiraling out of control faster than humans can intervene, consult, or de-escalate. Neither side might have wanted escalation, but the interacting machine speed cycles create it.
A loss of human control over escalation itself, that's deeply concerning.
It fundamentally threatens strategic stability.
Okay, so if this speed is operationally necessary, but it carries these huge risks, control, bias, flash wars, then the only way forward seems to be through really smart, robust governance.
Absolutely. The sources emphasize this strongly. It's not just about building faster AI, it's about building the right rules and frameworks around it.
It requires governance that's technical, procedural, and you mentioned cultural too.
Yes. One source explicitly called this as much a cultural challenge as it is a technical one, because it forces militaries and humans within them to fundamentally rethink their relationship with technology, information, and authority. It requires a culture shift.
So let's break down what that governance blueprint looks like. What are the priority actions needed to get this balance right speed with responsibility?
The sources highlight three key areas. First, tackling that opacity problem we discussed. Institutionalizing explainable AI, or XAI.
Explainable AI, meaning the AI has to show its work.
Essentially, yes, it's a technical requirement. The system shouldn't just give you an answer, attack target B. It needs to provide a clear, understandable rationale for why it reached that conclusion.
How does that help the commander on the ground?
It allows for meaningful oversight. If the commander understands the why, they can assess the recommendation's validity, build trust in the system, or identify flaws, and, crucially, make an informed decision to override it if necessary. It restores some of that human judgment.
Okay, XAI for transparency. What's the second priority?
Ensuring systems actually work as intended, especially under pressure. That means rigorous testing, often referred to by the acronym TEVV.
TEV.
Stands for Test, Evaluation, Validation, and Verification. This goes way beyond just checking if the AI works in a lab.
It means testing it in realistic, messy conditions.
Exactly. It includes things like adversarial testing, deliberately trying to trick or fool the AI, and comprehensive red teaming, where you simulate an opponent actively trying to defeat or manipulate your AI systems.
So basically trying to break it before it gets deployed in a real conflict.
That's the idea. You need assurance that these systems are reliable, secure against hacking or spoofing, and won't produce unexpected or dangerous behaviors when things get complicated.
Makes sense. Explainability, rigorous testing. What's the third key action?
This brings us back to ensuring human control at critical moments, establishing clear human authorization policies.
The actual rules of engagement for AI?
Precisely. These are the formal procedures and command policies. They need to explicitly define which decisions can be automated, which require human review or approval, and who holds the authority to authorize actions, especially anything involving lethal force.
It's about drawing clear lines in the sand.
Yes. It's the institutional commitment to maintaining meaningful human control, making sure there are unambiguous procedures and clear chains of responsibility.
And these national efforts, XAI, TEVV, authorization policies, they're important. But this isn't just a national issue, is it? The risk of flash wars involves interactions between nations.
Absolutely. That's why the sources also point to the critical role of multilateral norm setting. International dialogue and cooperation are essential.
Do places like NATO, the UN?
Yes, and organizations like the International Committee of the Red Cross, ICRC. These venues are vital for discussing and ideally harmonizing international expectations around AI in warfare.
What needs harmonizing?
Things like standards for transparency, levels of autonomy permitted, requirements for human control, data sharing protocols. If major powers operate with vastly different secret rules for their military AI, the risk of misunderstanding, miscalculation, and inadvertent escalation, those flash wars, goes way up.
So shared norms aren't just diplomatic niceties. They're actually crucial for strategic stability in this new era.
They are a strategic necessity.
Okay, so wrapping this all up, synthesizing this deep dive. The core message for you, the listener, seems to be this unavoidable tension. Future military effectiveness demands the operational speed AI offers, but harnessing that speed safely requires profound responsibility and careful governance.
That's the tightrope walk. The military forces likely to succeed long-term won't just be the ones with the fastest algorithms, but the ones who embed explainability, robust human control, and rigorous validation into their systems and culture from the ground up.
It really sounds like the definition of military power itself has shifted away from just counting planes and tanks towards who has the advantage in processing information and making high-quality decisions faster.
It's a paradigm shift, and it forces us to ask some pretty fundamental questions about global security architecture.
Which leads us perfectly into our final thought for you to chew on. If this race for decision superiority inevitably pushes towards machine speed, what kind of international rules, binding global norms, not just national policies, do we actually need to prevent those interacting automated decision cycles, these flash wars, from becoming the terrifying new normal in crises?
And what responsibility does each nation bear, knowing that its own pursuit of speed, however necessary it feels for national security, could inadvertently make the entire world less stable?
Something to think about. That's all for this deep dive.